Alrighty, hey there everybody. So what we're going to do for this is we're going to do De Moivre's theorem, where we're going to be able to find the power of our complex numbers, and then we're going to find the roots of those complex numbers, where the graph would cross the x-axis if we actually graph these complex numbers. So to find the power of a complex number, so if we have a number written in our trigonometric form, our complex number is going to be written in our trigonometric form, and we're going to have any power n. Then we can say that all of this, the whole trigonometric number raised to the nth power, can be rewritten like this, where we're going to say r to the n power times cosine n theta plus I sine n theta. Of course, this is how we can write it in our compacted form for trig functions. So let's give this a try. Let's find a power of a complex number. What I'm asking is, when I'm saying I find a power, what happens is if we take this value and we raise it to the third power, what will we get? Well, that is an excellent question. So to do that, we are going to take 5 and we are going to raise that to the third power, because we are finding z to the third power, the whole thing to the third power. And that's going to be the cosine of 3 times 60 plus I sine of 3 times 60. The 3's all came from the power. They initially said, hey, give it a cube root, so that's where those 3's came from. Now this is just going to be some algebra here. 5 to the third power is 125, and then we're going to do the cosine of 180 plus I sine 180. So if we look at the cosine and the sine value of 180, that's going to be at negative 1, 0. So 125 times negative 1 plus 0. And so we get negative 125. Now this is a complex number. We're writing it in our rectangular form because what we're saying is it's negative 125 plus no imaginary part. But we don't normally put this on there. I was just making a point. What if we want to write this in rectangular form? Excuse me, already we want to take this, raise it to the 6th power, and we want to write our answer in rectangular form. So when we write it all out, we're going to take our r value and we're going to raise it to that power. And then we're going to do cosine I sine of 6 times 85. And so the square root of 10 raised to the 6th power, that is 1,000. 6 times 85. So we're going to do cosine I sine of 510. Well, 510 is outside of my circle. So what we need to do is I need to find a coterminal angle with the 510. So let's find our coterminal angle. Make a little coterm. I couldn't remember how to spell terminal. There we go. A-N-G-L-E. Oh my goodness. So to find our coterminal angle, we're going to do 510 minus 360, and we find out that that is 150. So we're going to do 1,000 cis of 150. Alrighty, well, when we look at, if we go ahead and we find out what our x and y values of that are, so 150 has a reference angle of 30 up. So 30 up is going to be negative radical 3 over 2 and 1/2. There are my cosine and my sine values. So 1,000, the cosine of 150 is going to be negative radical 3 over 2. And then the sine of 150 is 1/2 I. So when I distribute, I'm going to get negative 500 radical 3 plus 500 I. Boom. Not so hard, is it? So it's a very hard sounding name to figure out what is actually something that's fairly easy. Alrighty, let's do this one. Let's express these. You know what? Let's go ahead and we're going to hit number 3 in class. So if you have any questions, please make sure that you jot them down and we go from there. Give this one a shot, but I will definitely go over in class with y'all. Have a great night, everybody.